Hello students, welcome back. I have a quick little video that I want to kind of share with you to kind of elucidate some things that I noticed on the exam um, that some students had some issues with. And I think it's very important that we don't walk away from this exercise not really grasping this concept. We obviously will revisit it later, but I just wanted to kind of go over it real quick, right? So, um, in the quick exam, now the PTC tasting, admittedly, we're not in class to do this experiment, but basically what it is it's the ability to taste bitterness in broccoli and Brussels sprouts. So the Punnett squares were filled in for you, and in the question was asked in the PTC example, what is the percentage that your child would be homozygous dominant, right? Okay, so let's address a few things. So remember that our homozygotes are going to be equals the same, right? Because homo. And then if we have heterozygote equals variation, right? So it could be different. 2, 3, 4, 5, 6, a multitude. But when you have homo, that's everything is pretty much the same. Whether you have 1, 2, 3, 4, 5, 6, or 2, 3, 4, 5, 6. So when we want to look at what we had, so the possibilities were, if we go back here, we could see that it's, we see a hetero, right? Another hetero, uppercase t, lowercase t, and then we see a homo, lowercase t, and then a homo, lowercase t, lowercase t. But remember that if it has a lowercase t, it cannot taste it. If it has an uppercase t, it cannot taste it. And remember that in order for recessive to be expressed, that a recessive gene needs to be, so we need homozygote recessive, which equals, in our case, lowercase t and lowercase t. However, that is a recessive. And if we want a homozygote dominant, we're going to want to have 2 uppercase t's, right? And then we can remember that our hetero, which you got this one, I think almost everybody understood this, that the heterozygote dominant, which goes to say heterozygote recessive, you can say it either way, has both the uppercase T, and the lowercase t. But what we were looking for in this exercise was this one. Which ones were homozygote dominant, right? And the same, but with the 2 uppercase t's. And so for this particular exercise, the answer was 0%, right? It was 0% because nobody had. There's no chance. There's no likelihood of the child, in any of your children, being born with a homozygote dominant trait to be a taster. So that was it. I just wanted to cover that. So thank you very much. We'll see you on Wednesday.